You guys, welcome once more in my YouTube channel. We're still under mathematics and 4. So I've given question 5. Alright, this is an integration. Right, this is the paper that was written now in July 2025. So I've given 5.1.5.1.1 says sketch the graph of y is equals to e raised to the power of x, right? And y is equals to e to the minus x, right? And then it says again, and x is equals to 2. Also show the represented strip as identity strip as well as the area to be calculated, right? That is what we have there. So let's try and scratch that graphs there. We have to scratch y is equals to e to the power of x and y is equals to minus or equals to e minus x, and x is equals to 2. That is it there. So and show the represented script. So how can you scratch the diagram of this? Alright, we want to scratch this. How can you go about that? Alright, so let me grab my Cartesian plane. Okay, let me just, alright, the line is very thick. The line is very thick. Let me reduce a little bit. Alright, so here it's our Cartesian plane. Alright, we have the x-axis and the y-axis. So how do you determine this format graph? Let's say now you don't know how you can scratch this graph. For you to make your thing, you can, let's say you don't know how to scratch, but this you must know. This is same, is the one of the, it's a typical question. It's a one of the exponential form. This it's an exponential graph, right? Let's say you don't know why it going to cut the y-axis. Let's say you don't know, you'll just use the standard format that says at the x-axis, or you can say at the y-axis. At the y-axis, you know that x is equals to 0. At the y-intercept, you know that x is equals to 0. Let's say you don't know. There you have this graph, y is equals to e. You just put 0 there. You know anything raised to the power of 0 is simply 1. Remember, that means you have the coordinates what? 0 and what? And 1, whereby it's y. Yes, you can see that means will be somewhere here. Our 1 is somewhere there. We'll have 1 there. So you understand that it's what you will have there. So, but this one has a positive exponent, and then here the value of k is it has a positive exponent, right? So you have to know that since as a it will be what, an increasing graph if you have any positive exponents. So your graph will cut there at positive 1. 0 is to 1 there. At that part there we have 1 there, supposed to cut there. So you simply just write your exponential form is going like that. You use the arrows to show it won't reach 0. You simply just continue like that. It won't reach where at the 0. So that is your point there. It's 1. There will have that point there it's 0 is to 1, the coordinate there. So what about this one? You see it's reflected where? At the y-axis. When you have a negative on the exponent, that means this is reflected where? At the y-axis. So it's the same thing, just now this will be that it's just the reflection of the original part. This is simply just reflected. You simply have still the same graph now. Will goes like this, will decrease, will cut exactly in the same value, but now will be increasing, will be decreasing like this. It won't reach to 0, it will go like that. See, that will be just an opposite of that. So also we have to scratch y is equals to 0. Y is equals to 0. The graph of y is equals to 0. You know the graph of y is equals to 0. You'll get it there. Let me just say -2, or let me, yeah, I can say here the -2. Okay, let me just do like this. Let me just have here, I can just say -2, it's here. Don't have to use the approximately scale there. I can just say -2, it's here. For argument's sake, +2, can write just +2 there. So I have to draw the line there of that graph. It's from 2 going up there. I'll use this hidden detail like that. That is the graph of what? Of y of x is equals to 2. It will contain is the one that I've highlighted with hidden details. Hidden detail, that is the graph there that I've used, or you can just, let me just use it, line. It's a straight line. So between these you'll have the represented strip. There between the two of the graph we'll have our represented strip between this graph there. That is how you have your represented strip. So you can calculate. Now we can use, we are done with this question. This is a graph of what? This one, you can say this is a graph of E of y. Let me just say y equals to E positive x. This one is y is equals to E to the minus x. We have now, this is your graph. You can have your full marks then. So 5.1.2 says now calculate the area indicated between the two functions by means of what? Of integration. So the area, we're talking about this area, we have used the represented strip, so will be between 2, is between where you see where these two graph enters, will be between this point and there. We want this area there where is represented there. So or the one of the represented strip, or we can use this represented strip, it's a rectangle part. Yeah, we can use that, the area there. So how can we get that area? We know we have 2, but here it's what is 0. The value of x here is 0. Remember here we have what is 0. Will be between these two, will be between the value of x when is 2 and y. So we'll have our lower limit will be 0 and upper limit will be 2. So the integral, this will simply equals to the integral. We want the area, isn't it? So the area will simply equals to the integral of the upper graph. What is the, between these two, they said they want this between the two graphs, the upper graph and the lower graph together there. So we have the upper one, we have there the upper, we have a minus, and then we have this one, the lower one. Between these two, the upper one, this is on the top, it's x raised to the power of 2. The lower one, it's e raised to the power of minus 1. So we'll take the integral of e raised to the power of x minus e to the negative x. All of this obviously will be what? Dx. We take the integral from which limit? From 0 boundary to 2. Here from 0 to 2. That is what we'll have. Now let us differentiate this guy. So we have to differentiate this. So obviously this will be the area. What is the integral of e raised to the power of e? It's simply the same as e, it does not change. We'll have e raised to the power of e. What about the integral of this? Will be check now, we'll have minus, right? The integral of e will be e raised to the power of minus x. Divide by what? By the derivative of minus x, which is what? Is minus 1. So this minus 1 and 1 will cancel. We'll have what? Positive. So you can simply write this to be what? We'll have positive. Right. So you have this. This is evaluated from where? From 0 up to 2. That is when it's evaluated, when we'll find the area between there. So we'll have the upper limit and the lower limit. So our area will take now e, where you see x, you replace the upper limit there is 2 plus e minus 2. All right. Subtract now the same thing, but now you take the lower limit, which is 0 minus plus. Okay, we have plus here, e minus 0 again. So this is what you will have. Then what will be the area there? So what will be the area? So you simply just check there. Okay. What is going to be the area? So you simply punch this on the calculator. You can punch all of this. Let's check what will be the area there. All right, we have e raised to the power of 2 plus e from my calculator raised to the power of minus 2 there, minus obvious e raised to the power of 0 is simply 1. We have 1 plus 1, still we have that 1. All right, so this will be what will be the answer. We'll have the area there will be 5.524 unit squared. This will be square units. That is what we'll have there. This is our area there. So we are done with that part. We have represented our area. So what about 5.2? We have this integral. They've given the integral of 2 there, as you can see. All right, so what is this? The integral from 0 up to 2 into 5 raised to the power of 2x dx. We want to evaluate, says evaluate this integral. So right, we have to determine the value then of this integral. All right, so let me write it here. Can erase here. We'll write it on the bottom. The integral from 0 up to 2 5 2x dx. This is what we have there. Let me just erase this part. All right, so let us take, now we have to differentiate this. All right, so the derivative of 5, they will have to integrate, not differentiate. So we have to differentiate this. You know, when you differentiate this, you'll write this as it is, 5 raised to the power of 2, but now divide by what? By the derivative of the exponents. Derivative of the exponents will be what? 2. Right, multiplied. Divide, multiplied by what? By ln. The base. We write the base here. What is the base? We have the base, it's what? Is 5. All right, 5. All right, that is what we have. Already, this is what we have there. So this is evaluated from where? From 0 up to 2. It's from 0 up to 2. So we'll have this. We'll have 5 2. When you see 2, you plug the upper limit. You start there with the upper limit. Divide by 2 ln 5. Right. We have plugged that, minus now the lower limit, 520 over 2 ln 5. So what is the value? This is same base. We'll just have 5 raised to the power 4 minus 5 raised to the power 0 divided by 2 ln 5. So what will be the value here? Punching this, what is what we'll get? Put this on your calculator. 5 raised to the power 4. This will simply equals to 1 anyways. Minus 1. Obviously, anything raised to the power of 0 is 1. 2 ln 5. You'll obtain a big number there, 100 and something. Let me check. 5 2 multiplied by ln 5 minus 5 big number. This will be 193,856 unit, square unit. This is the error. It will have square unit, or you can say a squared. You'll have square units. This is what you'll have there. So this is what you'll have. Yeah, that is what we have there. So let's try and check what we are given here. Again, we're given this integral 25 secant squared alpha minus 4 divided by 5 sec alpha minus 2 d alpha. All right, let's manipulate a little bit there. You must check there. Okay, we still have the integral, but this 25 you can 5, how can you rewrite 25. I think those is the difference. This is the same as 5. You have to see that it's a difference of 2 squares. You can do 5 is the same as 5 raised to the power of 2 secant squared alpha. Then this is the same as what is 2 raised to the power of 2 divided by 5 secant alpha minus 2 d alpha. So you have to notice there that on the numerator we've given the difference of 2 squares. Hopefully you've noticed that this is the difference of 2 squares. So we'll have 5 sec alpha minus 2 into 5 sec alpha plus 2 divided by 5 sec alpha minus 2 d alpha. So these two will cancel nicely, right? So there you'll be left at the end there you'll be left with the integral of 5 secant alpha plus 2 d alpha. So that is what you'll have there. This is the integral you'll be left with. So what will be the integral now? You have to take the integral of secant. Okay, let me just take, this is the same as you take the integral of this, will be 5 integral of sec alpha the alpha plus the integral of 2 alpha, like this. So let's take the integral of this, where this will be equals to, we have 5 multiply, what is the integral of sec? We check the integral, right? You have to check that. So this is what it is familiar there. We know that we have to take these two integral of this and that. You see, I've just separated this now together. So we have here, this will be ln, integral of this will be ln sec alpha plus tan alpha, right? It's there on your formula sheet there, plus now the integral of 2 is simply just a constant. Simply have 2 alpha plus constant c. Do not forget to add that. Do not forget to add the constant c. So multiply there, you'll have 5 ln sec alpha plus tan alpha, right? Yeah, plus 2 alpha plus constant c. This is your final answer there that you're supposed to obtain. So thank you for watching. Don't forget to subscribe to my YouTube channel and become the part of the family. Click the notification bell so that you'll be notified whenever I post a new video.